We now have a function that can take two sorted arrays and join them together into one sorted array. Now that merge is complete, we're going to go back to the MergeSort function, and we need to figure out exactly what this thing does. Clearly, we can kind of use our intuition here. The MergeSort function must take this input array, split it into two, and then eventually call the merge function. So definitely makes sense, but let's take a look at a diagram that's going to help us understand the full story here. All right, nasty looking diagram. This diagram shows an entire run through of the MergeSort algorithm. You can see that the diagram is essentially split into two halves. The first half is going to be where the MergeSort function comes into play. So that's the function that we have not yet written. The bottom half is everything that the merge function does. So this is everything that is done by the merge function that we just wrote. Let's now zoom in a little bit, and we're going to take a look at the different steps inside of here. The MergeSort function's purpose is to take some input array and divide it up into as small a chunk as possible. So my question to you immediately is, what is the smallest chunk size that we can turn an array into? Well, the answer is 1. At best, we can subdivide an array into one single element. We can't divide an element or an array any further than that. So the smallest we can divide an array into is one element. So let's take a look at what exactly happens. We pass in a full array to the MergeSort function. It is then going to divide that array into two separate and equal halves. We will then recursively call MergeSort again on both of those halves. So for example, 97,0 over here will get called or passed into a recursive call to MergeSort again. MergeSort will then take that array and again split it into two halves. So 97 and 0. 97 and 0 right here, these are still arrays. So we're never working with individual elements. We are always working with an array. We then recursively call MergeSort again with 97 and separately with 0. In that case, the MergeSort function would see that these two arrays both individually have a length of 1, and so they no longer can be subdivided anymore. So the MergeSort function is going to stop trying to divide this array and this array. Now I'm talking about these two arrays together, but recall when we divide 97 and 0 into two separate arrays, the result of each get their own recursive call to MergeSort. So really 97 gets passed on its own in its own single array into the MergeSort function. Now as soon as the MergeSort function sees that these two separate arrays right here can no longer be subdivided anymore, it realizes that it is now time to start calling the merge function. And it's going to start to try to merge these two separate arrays together. Remember, we had said that the merge function only works on sorted arrays. But if we have only one element in either array, well, technically it is sorted. There's only one element in both these arrays, but they are sorted because there's only one value. So we're going to pass in 97 as the left array to the merge function, and we're going to pass in 0 as the right array to the merge function. Now we just put together the merge function. Remember, if the merge function is given two sorted arrays, it will spit out one sorted overall array. So the merge function will join together 97 and 0 into an output of 0 and 97. Now the same exact process has been happening on the right-hand side as well. So 22 and negative 30, which was the first split that we did, got passed recursively to MergeSort. 22 and negative 30 got split into two separate subarrays. And then each of these were recursively passed to MergeSort. Again, MergeSort realized that it could no longer subdivide these two separate arrays anymore, so it decided to pass them off to the merge function. So the merge function sees 22 as the left argument and negative 30 as the right argument, and it joins them together into a single results array. Then these two sorted arrays are then passed back into the merge function again. So the merge function then joins together 0 and 97 and negative 30 and 22. And as we've seen, because we just wrote this function, if we pass in two sorted arrays to merge, it will successfully merge them together into one single array. So I think that the general algorithm here is kind of Not the worst thing in the world to understand. Essentially, we are splitting up an array into as small an element or as small a chunk as possible, which is an array of length 1, and then it's going to recursively start to join pairs back together. We have a function that is rock solid for joining arrays back together. So as long as we can recursively call that function at every step along the way, we know that at the end of the day, we'll eventually end up with a sorted array. I think that the real challenge here is just understanding exactly how the recursion really works. I mean, I can point at this diagram right here and I can say, oh yeah, here's how everything works. But when you start to take this diagram and imagine how you can recursively call all these different functions over and over again, that's where life starts to get really challenging. So let's take a pause right now. We're going to come back in the next video and we're going to start to put together our solution to the merge sort function. So I'll see you in just a minute.